Okay, good morning, everyone. First, thanks everyone for coming in this so early morning. So today I will talk about bring the Kubernetes to Arm64 edge node by K3s. And my session will cover 4 parts. So first is why we need this K3s project, and the second is what is this, and for sure that if we want to make this in a product environment, we should to have enhanced architectures to have a Kubernetes and a K3s cluster. Yeah. I will introduce myself. My name is Kevin. I'm from Linaro LDCG. I'm now working on the Linaro Developed Cloud. Yeah. So this is very famous today in cloud computing area. So that is the logo of Kubernetes. So the Kubernetes is run everywhere, and it is actually the cloud computing. Actually, I should say that it is a cloud computing operation system, just like the same level in with Linux in our operation system. And actually, it is a king for the platform as a service. So, but how we leverage this Kubernetes in our edge node? Because that for running one Kubernetes cluster, it needs a master and several worker nodes. So we can see in this picture. So for running is in one master node, it has multi components. We should set up the API server, the scheduler, and the control manager. Besides, we should set up the Kubernetes. So Kubernetes is interface to talk with the container runtime, and we should run the etcd to do the metadata service management. All of the components for one node will cost at least 4 GB memories. This is a nightmare for running on our ARMs, maybe on our ARM edge node, and it is a nightmare for running on Arm32. So that is several disadvantages now running the Kubernetes on ARM architecture. So first is, so most Kubernetes distributions don't support the ARMHF, Windows Arm32, because the key point is the etcd is not supported in this architecture. And the first is the Kubernetes node will easily cost 4 GB RAMs, and the other is the Kubernetes wasn't built for the offline management, because we need to maintain a cluster online, and if one node is offline, he could not do the self-management itself. So we can come to, there's a new project called K3s. The name was from the K8s. We know Kubernetes is called K8s, and the K8s minus 5 is called K3s. This project had launched by Rancher. It is a famous Kubernetes solution company. And the K3s is very simple and very easy to use the Kubernetes on the edge node. It has a low-light certificate Kubernetes. It can pass the Kubernetes conformance test and compatible with the Kubernetes API. Besides, all the K3s will be inside one binary, maybe less. Will be inside one binary, cost 40 MB, and the total running for the K3s will just cost 512 MB memories. And so for one binary, it can be running with one process and integrated with the Kubernetes API, Kubernetes and containerd. The K3s remove the Docker runtime because it costs more the API control expense. And K3s has a very good innovation that he uses SQLite in place of the etcd, because etcd is not available on ARMHF architecture. So it has released both the x86, Arm64, and ARMv7, maybe the ARMHF, yeah. So what it has done to do something to make that happen. So it has removed something and added something different. So from the remove part, we know Kubernetes has been famous in almost 5 years at least, and many features come to there. But several of them are legacy, and several of them are alpha features. So they remove all the legacy and alpha features that you don't need to use on the edge node. And it has removed the in-tree cloud provider. So what is a cloud provider is? The cloud provider is we can treat it as an API interface for talking with AWS, for talking with Azure, for talking with OpenStack. It is a interface to make Kubernetes to leverage the infrastructure as a service resources. So, but in K3s, we don't need this, so we remove this. And it has removed the in-tree storage driver because several storage drivers are implemented by several special companies, for example, EMC. So actually, it is not very useful for us, so we remove this. And remove Docker because it is, we use the container D, and we don't use the Docker runtime and API in the edge node. But it can also offer the container runtime abilities. And something to add. So the things to add is just the simplification for the installation. Yeah. For running a K3s, just one command is OK. And use the Circuit to support in addition to etcd. Also, you added the TLS management and automatic manifest and Helm chart management. Because in the edge node, we may need to set up several easy applications. So set up we use Helm will be very easy to do the things. And it has removed several choices for the container runtime, just the support container D, and remove other several choices for the DNS solution. Just use the core DNS, and the network drivers for this K3s now is just a Flannel. Yeah, because that the container running in the cluster, they need different network drivers for the interaction with each other. So we have many more solutions for Flannel, Calico, and many others. But in this architecture, for the multi-arc support, Flannel is to do the better. So we use this one. So here is a very simple K3s architecture, just the same with Kubernetes. So the only very different is the container. We use the Kubernetes talk to container D and remote Docker runtime, and also they have a internal proxy to talk with the Circuit instead of talk with etcd. Besides this, other process for the scheduler, the control manager, all of them are same. Here is a very simple command. Oh, maybe a little small, sorry. For running a K3s master, you just have one command. K3s server, it will be set up with your K3s servers, and you will get a K3s API server and set up the control manager and something else. And if you want to make a one worker node join this cluster, it is also very simple. You can run the K3s join, and you can join this cluster after you set up the server. So after you set up the server, you will get a hash code, and you can use this hash code to join this cluster. OK, so we can see that the K3s architecture is very simple, but we should say that just to have this K3s cluster, we could not make this on a production environment because it is all of things that it is set up manually, and there is nothing for the monitoring, nothing for logging, and nothing for operations. So if we want to bring this K3s to the productions, we should set up several things to management for the cloud to the edge sync, and the total operations. So let's see what rancher do. First, I can show the pictures is what rancher do. Because rancher has developed this project, but we know that rancher is a solution company, so they will also do a unified cluster operations, and they want to let people use their solutions. So that solution is definitely not an open source project. The idea is he will run a unified cluster operations on a cloud node, maybe on a cloud node to do the provisioning, to do the security, to do the capacity and the policies, also to do the role-based access control. So all the things in the green background will be running in the data center level, and the K3s clusters, that is, they will be running in the edge level. And this architecture, these K3s clusters will be managed by the cluster of Kubernetes that are running in the data center level. So we can get some ideas from this and do the open source solutions. So that is what we do now to enhance this architecture. So next, that is what we defined to enhance this architecture, to make K3s on our production level. So we have set up a K3s operator. The operator concept I will show in the next slides. So this operator will do the cluster management, will do the provision, monitoring, and the application deployment. And we can leverage a component called K3s Op. That is an open source project for user to easily set up their cluster on a remote node. It is something like a operation terminal, just the same with Ansible, but it's dedicatedly for the K3s, so it is very easy to use. And on data center level, all the K3s operators and K3s Op, they will be located on one Kubernetes clusters running at data center level. And besides, it can set up the edge node on the edge level. Yeah, you can connect different edge node to these clusters. And here I'm lacking our VPN terminals here to connect the data center level and the edge node, because we should make sure that they are in the same network, and the VPN terminal is the best solutions and the easy solutions for this. Here is, I should say, what is operator today. Operator is, there's two concepts with operator. First is a custom resource definition. We call it CRD. So it is a very famous concept now in Kubernetes, and it is a key concept for running things cloud native. For the CRD, there is two things I should mention. One is the API. So in Kubernetes, we define custom resource definition at the CRD, and we can introduce your own resources into Kubernetes cluster. And the API will follow the rules of Kubernetes. And the other is the CRD content, the CRD file itself. We can define what you want in this CRD file. And the API server will take care of this, take care of the CRD files lifecycle. Sorry. So after we can see the CRD is just what you define, and you can make the Kubernetes cluster you can make the Kubernetes API to take care of your resources. But we should say that it can't just do the things at API level, at the metadata level. How could it do to interact with your other system? Because that we need an operator to talk with other system. For example, we can use a etcd operator to make Kubernetes talk with etcd cluster and do something with etcd. And we can have the Kafka operator and the Prometheus operator, also the OpenStack operator. Each of them can do different things with a different target system. So the operator is, first he will watch the CRD file, the difference, from API server, and you can define your logical. You can define your logical in this CRD, in this operator, to have to do the right logical scheme. So here is the thing that you need to design. And so after do these things, you need to update the metadata informations to the database, to the API server. So that is a different operation method, just the same as a traditional, just the different with the traditional operations, because that all the things, all the operations and all the actions will be act in the Kubernetes framework, and all the resources will be managed at the Kubernetes etcd. So you can define your different operator with different target system. And that will make your Kubernetes to take care of all your target systems very easily. And you don't need to have another storage for store your actions and status. Just the etcd is enough in your cluster. Here's the control process of operator. It is very simple and just have 3 parts. So first is observe. Observe is it has watched it has watched a CRD object change from the API server. And after he observes these things, he will analysis. For example, the CRD file has been defined to 3 parts. First is metadata information about the CRD things, the name, the label, and other things. And the other one is the spec. The spec is what we want to do. It is a desired state for this CRD. For example, I have defined I want 3 pieces of bacon, and the third part is the current state. For example, the current status of now is I just have 1 bacon. So after analysis of this, I found that I need to produce another 2. So in this operator, it will call the API from the bacon factory. It says that I still need to produce 2. So after that, the factory of the bacon will produce, maybe it will produce 1, and then he will update the CRD object. The status is 2, and we will also enter into another control process. The state is 2, and the spec is 3. So we need to continue to produce. And after the current status and the desired status is the same, the process will be finished, and this CRD has been marked finished and exists. So that is a round robin. That is something like the round robin, and it is a core logical system in Kubernetes. All the Kubernetes resources, such as the pod service, the daemon site, all of them are the same actions. But you should define the operator logical yourself. And besides this, we have leveraged a project called K3s Node. So K3s Node is operation terminal. It can very easily to install the K3s Node in K3s on different node. For example, we can use the K3s install on a Raspberry Pi and use the K3s join on another node, so that they can connect it with each other and have a K3s cluster. So that is easily terminal, and use the SSH drivers for this action. So after I talk all of this, so that is the K3s operator we have defined, and we have modified to this. So first is we have defined the custom resource definitions We have K3s Node 1, and with the IP, SSH port, and type is server or agent. And also we have several parameters, maybe skip install, because we have already installed. And we have defined the password. So we have set up the password in another Kubernetes object called secret. So after this, the Kubernetes the K3s operator watch a change that the user has applied a CRD file K3s Node 1 on it, and it will call the K3s up and set up the K3s on the edge node. So and then after finish, it will update the CRD change, and one K3s node will be joined in this cluster. Yeah. And welcome to join us in the small demo in Demo Friday. So today the time is up, so I don't have time to show this small demo. And thank you. Any questions?
My understanding is that K3s is primarily in the edge, right?
Yes, it can be dedicatedly used in the edge.
If I deploy the K3s in the edge, how many disk size or the RAM size the K3s will consume?
Disk size,
Yeah.
maybe less than 1 G is okay, and RAM size is less than 512 MB.
Okay, cool.
Is enough, yeah.
Cool, thank you.
Any question?
If the application already wrote by the K8s and now we change to the K3s, how many efforts?
No effort, because that they had K3s is another K8s distribution, so the application can running on the same on a different platform.
You mean the script or something can be used
Yeah, if
directly?
you have a container image, you can run it in K3s. Very easy.
Okay.
Yeah. You can treat it as another Kubernetes distribution, but it's a simple distribution. Okay. Okay, thank you.